Okay, so today, viewers, we're going to talk about very important foundations about doing inferential statistics. So we are also giving out this free PowerPoint presentation to everyone so that you can use it for your classes or for your own personal reference. Don't forget to subscribe and like the video, and go ahead and comment in the comment section. And after doing that, please go ahead and go to the video description. There you will find the link for downloading this PowerPoint presentations. Alright, so we're also giving out a free e-certificate to those who will be able to complete this course. So go ahead and watch the video from start to finish, and try to click on the link in the video description for your e-certificate proving that you have completed this course. So go ahead and listen carefully to the discussion so that you'll be able to answer the questions required before receiving your e-certificate. So without further ado, let's go ahead. Right. So the main question is, what is statistics? So we need to really understand what is statistics first. So statistics is the study of how to collect, organize, analyze, and interpret numerical information from data. So as you can see from the definition, this involves collection, right? And after collecting the information, you need to organize them in a way that will help you analyze the information properly, right? So in the process of analyzing the information, it's very important that you interpret it in the context of the situation that you are in. And oftentimes, this is used for decision making. So for all the teachers, school leaders that are watching right now, or for those who are in the profession wherein research is very important, and those who are making very important decisions, if you want to make wise decisions towards your work, to whatever you are doing right now, which is vital and which will affect other people, it's very important that you know how to study statistics and how to conduct statistics, right? So what is statistics again? It is important in decision making. So in our lives, we are often asked to make important decisions. We try to make choices, but the world is uncertain. It is ambiguous. There are many things that we can't predict. But if we want to be more scientific in how we make decisions, then it's very important that we do, embrace statistics, because this will help us create and make wise decisions. So we make decisions based on the information we have. And that is also affected by our attitudes and our values. Okay, so when we make decisions, please be mindful that we base our decisions based on what we know. Okay, and what you know sometimes is really limited. You are just saying the tip of the iceberg. So it's very important, as I've said, that you know how to conduct statistics, gather information, interpret it properly, analyze it properly so that you can make the right choices. But more than that, we also have our attitudes and our values that actually affects how we make our decisions. So statistical methods help us examine information. Okay, so this is the power that is given to us when we know statistics. So moreover, statistics can be used for making decisions when we are faced with uncertainties. Again, as I've mentioned, the world is uncertain. We can't really predict, and it's very volatile to the point that things can change every now and then. Okay, so you need to be able to make use and maximize the information that you have, so that in the long run, you'll be able to make good and wise decisions. So what is the purpose of statistics? The purpose of collecting and analyzing data is to obtain information. As I mentioned, statistical methods provide us with tools to obtain information from data. And then statistical methods enable us to look at information from a small collection of people or items and make inferences about a larger collection of people or items. So as you can see here in the picture, you see here a clock. A time is very precious. Okay, so considering how important information is, so you need to really be aware. But however, you don't have the luxury of time. Okay, so you need to make the most of the information you can collect from a small amount of people. So we actually call this sample in statistics. So the beauty here is that from a little sample of what you want to know more about, you'll be able to make inferences out from the general population, right? So out from the very sample you have, you'll be able to learn and make insights about what the greater population is. Well, that's the beauty of that. You are given the luxury of time. You save time. You don't have to go to every member or individual of the population that you're studying. You just have to collect a small sample, and we call that a representative sample as much as possible. Then you'll be able to deduce and to infer as to what the characteristics of the whole population is. And that is the reason why it's called inferential statistics. Right. So what are the different methods? So this includes descriptive statistics and inferential statistics. So what we do under descriptive statistics, we will get to know that later on. So the procedures for analyzing data together with rules of inference are central topics in the study of statistics. So we should also focus on understanding both the suitability of the method and the meaning of the result. So under statistics, you talk about or deal with the procedures of analyzing data and then how to make wise inferences. So we should also focus on understanding both the suitability of the method and the meaning of the result. Okay, so part of statistics is really the ability to interpret the results based on the procedures you have conducted. So that is also part of statistics. So under descriptive statistics, what you really do is that you do some organizing, picturing, and summarizing of information. I think we are familiar with tables, graphs, and summary measures. In this way, you'll be able to create, organize the data in such a way that will provide you more insights as to what the important points are and make you find out what are the things that you need to know about what data you currently have. So we also have inferential statistics involves methods of using information from a sample to draw conclusions regarding the population. So right now, it's a little bit different. You're going beyond describing the information. So at this point, you are already looking at the information and trying to make some conclusions, or this is what we call inferences, out from the little information you have. So you are going beyond just describing the information. You are now making judgments, making a very wise decision or assumption based on what you see. Okay, so this is inferential statistics. So as you can see here, this is a summary of what we have discussed a while ago. So there are two types. We have descriptive and inferential. And again, for descriptive, we just do the collecting, organizing, and we summarize it, present the data. If you know how to do pivot tables, do slicers in Excel, this will actually help you do really good descriptive statistics. Okay, and then we also have inferential stats. So this includes making inferences and creating hypotheses and testing it, and then determining the relationships between two variables. And then the most powerful part is that you'll be able to make predictions out from the information that you currently have. Let's now proceed to the basic terminology. So individuals or people or objects included in the study. So remember, the individuals in statistics are not just human beings. They could be objects that you're referring to. They could be a rock you're studying, whatever it is that is a point of interest for your research. And then a variable is a characteristic of the individual, of that object or that people that you want to be measured or observed. Say, for example, you're studying all the human beings in the world, then those are the individuals of your study. And then if you're studying the weight of these individuals, then the variable that you're currently studying is now their weight. Okay? So these are just very simple terminologies, but we need to be aware of these terms. Okay? And then we also have quantitative variables. So this is, we love measuring things. So when you are in statistics, we love putting a value to every characteristic that we see. So we call this one a quantitative variable. So it has a value or a numerical measurement for which operations such as addition or averaging make sense. And then we also have qualitative variables. So this describes an individual by placing the individual into a category or group such as a male or a female. So this is another form of a variable which is non-numerical. So you usually use this to categorize the individuals in our population. So an example is gender. An example is a classification perhaps that will determine what particular group that individual belongs. Okay, so we usually call this one categorical variables. So these are qualitative variables. All right, so another term that we need to be aware of, which I've repeatedly mentioned a while ago, is the word population. So it consists of all elements that are being studied, right? So every individual under the point of interest that you have is what you call population. But if you are studying this whole population and then you just wanted to get a few samples out from the population, then that subset of the population is now what you call a sample. So a census, if you hear the word census, it is a sample of the entire population. So basically you are, trying to pick up every individual that you have in your population. Okay, so as you can see in the illustration, population, you are taking out a few of the individuals there. Okay, trying to study the whole population out from it and then studying this small sample to make inferences as to what kind of population you have. Okay, so if you hear the word census again, all of them are included. So that's census. So in population data, the data are from every individual of interest. So you are collecting data from all of them. You're not missing out anyone, really all of them. And then in the sample data, the data are from only some of the individuals of interest. So getting only a few of the samples from the population, right? And then making conclusions out from it, right? So if you hear the word parameter, it is a description or a numerical measure that describes the population, okay? An aspect of that population. So parameter is for the whole. None is missed out. Everyone is included. But when you hear the word statistic, it is a numerical measure that describes an aspect of that sample. So basically, you are just collecting a small sample out from that population and you're describing it. And that aspect that you're describing is a form of a statistic. Okay, I hope that's clear. Right, so let's go now to some examples. So, for example, the government is conducting a study of ready to harvest bananas in an experimental field. So your point of interest now is the bananas. So what are the individuals here? Although they are bananas, we still call them individuals because statistically, under statistics, this is how we call them. So the bananas are the objects, so we call them the individuals. So if the researchers are interested in the individual weights of the bananas, then the variable are the weights. Okay, so the weights could be measured to the nearest ounce or gram. So weight is a quantitative variable because it is a numerical measure, right? So if weights of all the ready to harvest bananas in the field are included in the data, then we have a population. Okay, so if you include all the weight of all the bananas you find in the experimental field, then you have a population. Then the average weight of a tall ready to harvest pineapples in the field is what you call a parameter. Okay, so as what we mentioned a while ago, we are really fond with measuring. Okay, so what is measurement? So as you can see there, we are fond of measuring our height, our weight, and almost anything else in the world. Okay, because we wanted to be consistent and to be able to communicate what we have to another person. Okay, so measurements are standards set by people. So we have categorized, we try to measure things so that we'll be able to communicate it, put standards to it so that we'll be able to, concretize something that we see in a particular object. So there are specific levels of measurement. So basically when we measure, as I mentioned, we are describing it. Okay, so there are levels of measurement and which often confuses our students. But let's try to imagine what power is given to every level of measurement that we provide to a specific individual, okay, of study. Okay, so I will try to explain this very simply so that we'll be able to understand it. So another way to classify data is according to one of the 4 levels of measurement. So these levels indicate the type of arithmetic that is appropriate for the data, such as ordering, taking differences, or taking ratios. Okay, for example, the most basic is what you call the nominal level of measurement. So this is the lowest level, and it only provides from the word nominal, it means naming. So the value that you assign to a particular individual is just for the sake of categorizing it. You don't have the power to know which one is greater, which one is lower. An example of this is the basketball jersey number of the basketball players. So we see there 5, 28. They can, even there's a 0. There's a player, NBA player, which uses the number 0 to show that he was nothing and now he is doing something to make a difference to the lives of, so beside the fact that he has a 0 number, it doesn't mean that he is not a good player or he is the best player or whatever it is. It's just for the sake of naming or labeling that person. Okay, so again, it's the lowest level of measurement, and we call that one the nominal level. Okay, so I think you can guess already what's the next level. So the next higher level is that right now you'll be able to determine which one of them is higher or lower. Okay, so an example of this is, the value first, second, third, fourth, fifth. Okay, so imagine there are people who are, having a race. So as you can see here, the first finisher is very far from the second placer. Okay, so as you can see, we have here the first, then we have the second, and we have the third. Okay, so by labeling them or measuring them that this is the first, and this is the second, and this is the third, then you'll be able to determine which one of them came first, which is a little bit different from a little bit higher level compared to the one that we have done a while ago, because we can only, label them and categorize them, but we don't have an idea which one is greater or lower. But in ordinal level, we'll be able to determine already which one has higher value. So we can see here, this is the first, this is the second, the third. However, as you can see, we don't have the power to determine the distance between the first, second, and third, and so on and so forth. It could be that from first to second, their distance could be very high. Okay? And then from second to third, their distance could be very slim. Okay? Around 0.0001 centimeter perhaps. Okay? So, but no matter what you say, the first one is the first, second, and third. Okay? So, we can really apply this in our lives, no? I remember when I was a student, the valedictorian has an average grade of 99.98%, and the salutatorian has 99.96%. So as you can see, if you use statistics on that, their scores are really very, there's a little difference between their scores, but surprisingly, no matter how you view it, the valedictorian will always have all the accolades and all the awards. Okay, so for a little difference in their intelligence, a very slight difference in their intelligence, there is a lot of prize given to the first placer, to the valedictorian. So this is reality, but when you use statistics for that, they are actually very much statistically equal. Okay, so they're just equal in a sense. Right now, you try to guess what will be the next level. Okay, so I guess you can already see. So in the next level, perhaps, it will answer our concern that we have raised here. The distance between the first, second, third, and whatever it is. Okay, so it's what you call the interval level. So under the interval level, you'll be able to determine the distance between two specific variables. Okay, unlike the ordinal level wherein you can only label them as first, second, third, fourth, fifth, but you will not be able to determine the distance or the value of distance between those, rankings that you have mentioned. So under interval level, you'll be able to see that. So the level of measurement applies a data that can be arranged in order. In addition, differences between the data values are already meaningful. So as you can see, there is already order. Okay, there's also the ability under interval level. You can also know which one is higher, which one is lower. Okay, so it has the power of the ordinal level. You can determine the rank or the value of each number. And additional power is that you'll be able to distinguish the differences between the data values. And you can also name them. So as you can see, there is a hierarchy. Okay, so the interval level has the power of the ordinal level, and the ability of the nominal level. Okay, so the highest is what you call the ratio level. So the ratio level of measurement applies to data that can be arranged in order to take the differences and find the ratio between data values. So this is already higher in a sense that you'll be able to take the ratios of two different information or data, and then their ratios will be of value. Okay, so as you can see here, in the interval level, there is no true zero here under the interval level, but in the ratio level, you'll be able to determine when you say zero, there will always be that is really equivalent to zero. So oftentimes it's called the true zero value. An example of that is your weight. Okay, so for temperature, you cannot really say if it's zero, it doesn't really tell you that there is no temperature. Okay, so there's no amount of heat found in that thing. Okay, so but if you talk about weight under ratio level, then when you say zero, it means there's zero weight, right? There's zero mass. Okay, so that's the difference between interval level and ratio level. So in order for you to determine the level of measurement for a particular value that you're referring to, value of measurement you're referring to, all you have to do is to use this table. So if you can put the data into categories, then that's nominal. But if you cannot do the ordinal, then you go to nominal, right? So if you can put the data into categories and you will be able to group them as to smallest or largest, then you're dealing with ordinal level of measurement. And if you can do the nominal, ordinal, and the interval, we can order the data, and you can also take the differences between the data values at this level. You can compare the differences between the data values, then you are dealing with an interval level of measurement. But if you can also do all these three, the nominal, ordinal, interval calculations here mentioned, and you can also order the data, take the difference, and find the ratio between the data values. For instance, it makes sense to say that one data value is twice as large as another, then you are dealing with a ratio level of measurement. Okay, so as you can see, there's a hierarchy, and each hierarchy actually has the power of those who of the lower levels. All right, so in order for you to measure properly, you need to collect samples. So let's talk about sampling. So a simple random sample of n measurements from a population is a subset of the population selected in a manner that such that every samples of size n from the population has an equal chance of being selected. So let's just deal with the important points here to make it very simple. When you do random sample, if your main goal is really to have a representative sample, okay, something that will represent the whole population as much as possible. So what you do is to randomly select each one member of the sample. When you say randomly select, there should be an equal chance of every individual in the sample to be included to your sample. Okay, it's not just because the person is very near to you that you will include him. Okay, those who are far from you, you should include them. So we call this one simple random sample. So how do you do a random sample? So first, what you need to do is to number all members of the population sequentially. Okay, so every individual, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth, depending on how many n you have. Okay, then use a table calculator or a computer to select random numbers from the numbers assigned to the population members. So the next thing you're going to do is to use a table, calculator, or a computer to select random numbers. So you can also do this by creating a fishbowl and placing all the numbers you have labeled from the individuals, and then randomly drawing them from that fishbowl, okay, so or whatever container you have. Okay, so giving an equal chance to all the members of the population to be taken as the sample. Okay, so you can actually do this using a calculator or a table, whatever it is. Just randomly select any number that you can see in the table or calculator. Computers can also do this very well, right? So if you don't have any of those, then just do the ancient way. Okay, so you get a container, place all the numbers there, and randomly pick one number. Then create the sample by using a population member with the number corresponding to those randomly selected. As I've mentioned, you randomly pick 1. Okay, So that will be now your sample. So what are the random techniques? So you use a simple random sample from the entire population, right? So that's a random sampling. And we also have stratified sampling. So let's say, for example, in the entire population, there are different groups found there. Okay, so how do you do your random sampling so that you'll be able to get a representative sample? So of course, you group them by their subgroups, and we call this one strata, and then give equal chance for every group to be randomly picked. Okay, so you are already doing stratified sampling, okay, giving equal opportunities to all of the members of the different groups. Okay, so we have systematic sampling. So in this way, you also this is a form of doing random sampling, which is a little bit fast. So you just number all the members of the population sequentially. Then from a starting point, select at random, include every specific number or member of the population. So all the second member down will be included to the sample. Then we also have cluster sampling. So this is a form of stratified random sampling. So divide the entire population into existing segments of clusters. So you group them, and the clusters are often geographic. So the difference between stratified random sampling is that for stratified sampling, it is more of their characteristics. For cluster, it is more like of geographic location. Right? So make a random selection of clusters, include every member of each selected cluster in the sample. Alright, so let's proceed now to multi-stage sampling. So we use a variety of sampling methods to create successively smaller groups of each stage. So the final sample consists of clusters. So as you can see here, there are multiple stages of sampling that you are doing across the process, so that you'll be able, again, the idea here is to have a representative sample. And the most very commonly used when you are doing qualitative research is convenience sampling. So what you do is that you create a sample by using data from the population members that are readily available. This is actually a no-no in quantity. If as much as possible you try to avoid this because you are only getting a sample from those who are very much convenient in your part. However, in times when you do qualitative research, there are times that this is very helpful, especially if you're still collecting information and just want to get started with your research. Okay, so there are two things that you need to take note when doing sampling. So this is what you call sampling error. So what happens is that, remember that you are taking a little sample from the whole population, right? So it's very important that you take into consideration that whatever you collect might not be representative of the whole population. So the difference between the sample that you have, the characteristic of your sample, and the whole population is what you call the sample error or the sampling error. Another thing you need to take note is what you call the non-sampling error. So the non-sampling error is the result of poor sample design and sloppy data collection. So let's say, for example, you just collect information from those who are nearest to you, and you don't really employ the methods of random sampling. So as a result, there are many mistakes. The sample that you have is not really representative of the whole population. Thus, you will not be able to create wise and appropriate conclusions. So as much as possible, you avoid this. So the difference between non-sampling error with sampling error is that non-sampling error is the fault of the researcher. So you should not be biased. You should be objective in how you collect your information, and you employ the methods stated here as much as possible. Give equal opportunities to every member of the population to be included in your research, right? So we have planning a statistical study and gathering data are essential components of obtaining reliable information. So in every for every statistical method that we employ, it is usually connected with a research, right? So this will greatly help you if you're conducting your research, get to know statistics, and you'll be able to create a very good research project. So depending on the nature of the statistical study, a great deal of expertise and resources may be required during the planning stage. Especially in statistics, you need to plan very well. So how do you do a statistical study? First is identify the individuals or objects of interest. So what are you interested to? What are you studying? Right? So what are the things that you wanted to know? So that answers now the number 2. So from the individuals of interest, you now try to describe what are the characteristics that you want to get to know out from the individuals that you wanted to study. So these are now called variables. Okay, so try to see how are you going. Your next question is, how am I going to measure these variables, right? And how am I going to collect them? So determine if you will use the entire population or just a representative sample to save time. So if using a sample, decide on the viable sampling method. So try to see which approach, as what we've mentioned a while ago, which among them is really appropriate for the situation that you're currently in. So in your data collection plan, address issues of ethics. So it's very important that you consider ethical considerations. Okay, that includes confidentiality. So you should not divulge information, and you should respect their privacy as much as possible. So if you're collecting data at a business, store, or college or other institution, be sure to be courteous and to obtain permission as necessary. So always do the protocol, right? And then if you're done with doing all this, you can collect your data. And then use appropriate descriptive statistics methods and make decisions using appropriate inferential statistics methods. And finally, note any concerns you might have about your data collection methods and list any recommendations for future studies. Right. So let's now proceed to one thing. One issue to consider is whether to use the entire population in a study or a representative sample. And then if we use data from the entire population, we have a census, as what we have learned a while ago. Then if you use data from only part of the population of interest, we have a sample. So please be mindful of your terminologies as you do your analysis and as you do your description of the information that you have collected, especially in the results and discussion part of your research. So in an observation study, observations and measurements of individuals are conducted in a way that doesn't change the response or variable being measured. Okay, so you have the option also to observe. Okay, so in this way, you'll be able to really get the purest data that you can. So in an experiment, this is a little bit different because in an experiment, it's a controlled situation or an atmosphere wherein you control most of the variables and you just, test one variable at a time as much as possible. So we call this variable the independent variable. So there is a deliberate, we impose on the individuals in order to observe possible change in the response of the variable being measured. So those are the two possible scenarios that you can do. And please take note of the placebo effect. So this occurs when a subject receives no treatment but incorrectly believes that he or she is in fact receiving treatment and responds favorably. So, human beings usually have this mental state wherein we think that, something will benefit us even if it doesn't. So there is what you call a placebo effect. So if you're doing an experimental study, you should have a positive and a negative control in order to check this. For you to visualize this, let's say, for example, you have a medicine that you want to test. So you give this to your test group. So the test group will have a dose of the real medicine. And there will be some of the members that will think that they have received the medicine, but actually it's just a placebo. Okay, so it's not the real medicine at all. Okay, so only you as the researcher will be aware that medicine is the real one. But remember, there are ethical considerations that you need to consider in this situation. But if you're thinking that a placebo effect is possible because human beings might assume that there's something by just knowing that this is a medicine, then you might as well as do that. But you need to really justify it using your ethical justifications as much as possible. Okay, is it for the greater good of humanity or whatever it is? Okay, and if doesn't put or place the person in any form of harm. So you need to consider all those things. So we call that the placebo effect. Okay. So we also have, once you decide whether you're going to use sampling, census, observation, or experiments, or a common means to gather data about people, is the next thing is you need to ask questions now. So this is the process or the essence of surveying. Right. So let's now go to the last part, and let's try to see what possible problems might this person encounter as they do data collection in their respective research. So a situation here is that a guidance counselor interviews a group of 20 college freshmen, and she asks each one of his or her name, and then she also asks if they use illegal drug in the last month. So what possible problems might this teacher encounter? Guidance counselor teacher will encounter. Well, as you can see, respondents may not answer truthfully. So there is a stigma on the question itself. Okay, so we know that drugs is illegal, and who will, in the right mind, answer you properly if they're using drugs? So they will not answer truthfully. Some may refuse to participate because they do not want to incriminate themselves. So the information that you gather here, if you pursue this, then will not be accurate at all. So a survey about food in the student cafeteria was conducted by having forms available for customers to pick up in the cash register. Then a drop box for completed forms are available outside the cafeteria. So what will happen here? Right? Anyone? So the answer is that the voluntary response will likely produce more negative comments. So, those who will really just take time to answer the survey are those who are already very irate, and those who are really angry, because they will have the audacity to really provide that feedback, given requires you to fill it up in the cash register and then really bring it out there outside the cafeteria. So it's not really convenient at all. So the response will most likely be negative. Again, the information that you'll be collecting is not accurate. Why? Because you're just collecting all the negative information. How about the positive responses, right? Or the positive, reactions. So you'll not be able to collect all of those, right? So extensive studies on coronary problems were conducted using men over age 50 as the subjects, right? So what do you think? Well, the conclusions here are only for those who are 50 years above. So you cannot already generalize to other age and gender groups. So in order for you to really have a better grasp of the insights from other groups, then you need to conduct more studies regarding this one, right? So lastly, let's end with this saying: statistics can be made to prove anything, even the truth. Okay, so this saying actually tells us that sometimes the truth is not that obvious at all. Okay, so oftentimes there are many people all around us that refuses to see the truth. Okay, so me as a teacher and a school leader, as a supervisor, I've been through a lot of things, and I've seen that people sometimes even refuse to see the truth. So there are times that you need to do and learn to love statistics, because people in the long run needs to see the truth in many ways. Okay, so in order to create the change that you want to create, you need to use the proper tools, the tools that will increase your likelihood of being believed in, the ways that will help you increase the odds of you being followed. One of the tools that you can have is statistics, right? So if you want to learn more about statistics, and if this video really helped you, don't forget to like and subscribe to this channel, because I'll be uploading more videos regarding statistics and research, and also about our craft in teaching. So if you want to improve your craft in teaching, honing you as a teacher, as a leader, or as a principal, or a supervisor, go ahead and subscribe to this channel. And again, congratulations for completing this training regarding the basic foundation of statistics. Go ahead and check on the video description. You can have an e-certificate that will prove that you have completed this part, right? But before that, you need to answer a few questions. And after doing that, you'll be able to receive your own e-certificate, proving that you have completed this training. Congratulations, and thank you so much for being here in our channel. Don't forget to check other videos under Learning with Doc Labs channel, and don't forget to share this with your friends as much as possible. Do not download this video. Instead, you can download the PowerPoint presentation instead. I'm giving it out for you, to you for free, because I love to help teachers, right? So thank you so much, everyone, and God bless. See you in the next video.